JavaScript source code is getting faster and faster and faster every week. Additionally, of course, we have one language to rule them all. So you've got your JavaScript on the server and your JavaScript in the browser. So we're able to use that institutional knowledge of JavaScript, of the language, of how JavaScript works on both the server and the client. So we can reuse a lot of that understanding versus separating out people into you're a front-end person, you're a back-end person. That doesn't mean you don't need DBAs. I'm sure you will, but it does mean that we can reuse a lot of that institutional knowledge. We have a very solid standard that is being developed actively. I know it was in a sorry state maybe a decade ago, but it's actually quite good now, and it's improving each year. So ECMAScript is improving each year, and because of that, the language is improving all the time. And the vibrant ecosystem, that kind of builds off of the standard a little bit, but when you start looking at the number of packages that are in the Node Package Manager, it's quite insane how many there are. But it's not just the number of packages that are available, it's also the community around those packages. It's the communication that's happening in GitHub and on Google Groups and user groups and webinars like this. It's that community, it's a very vibrant ecosystem, and that's helping push Node along. Of course, there are some caveats to using JavaScript generally and certainly on the server. First of all, one of the big ones that I see with every single time that I do a training or a workshop or a webinar like this is people have to shift their thinking into async, which means you have to start thinking about your code in an asynchronous manner. Not just a little bit of your code, not just the AJAX call on the browser, but every bit of your code. You want to think about how you can use the asynchronous nature of Node. We don't really have a lot of very, very mature frameworks and tools. They're getting there. StrongLoop's helping with that with Express, which has been around for quite a while, and with Arc for the DevOps side of things. But, you know, those tools are coming along. They're not as established because the framework, Node itself, hasn't been established for terribly long. Also, we have to worry about callback hell in JavaScript. All this asynchronous action requires callback functions to execute. And those callback functions, of course, can get nested, and then we get into this idea of callback hell where you've got functions inside functions inside functions that are all untestable. So we have to implement some way to get around that. Now, we're not going to cover a whole lot of that in this particular talk simply because we don't have a whole lot of time. However, if you're really curious about that, some great solutions for that are things like promises. The async library in Node is a very, very popular course for that to correct those kind of issues. And then, of course, there's the JavaScript quirks that we have to worry about, and JavaScript has an abundance of these. Everything from the type of null being an object to -1 equaling an empty string. So there's all sorts of weird things that can happen in JavaScript, so we have to be cautious of those. Every language has these quirks, but JavaScript has quite a few of them. And in case you're curious, Node is not just for Silicon Valley hipsters. It's not just for people on the bleeding edge. It's being used by companies large and small. All sorts of businesses are using Node to power their APIs. Big, big, big players like PayPal and Netflix are using Node on the back end. LinkedIn reduced the number of servers that they were running from 27 to 10. And how did they do that? They just switched to Node. They rewrote their application in Node, and they're able to reduce the number of servers they have. Node is really coming along in the enterprise, and it's ready to go. Now, some Node specific, some things just about Nodes specifically. Node is single-threaded, and what that basically means is that it runs in a single process. So whereas in something like PHP, you might have multiple processes that are running multiple different instances on your machine, Node runs in a single process. There's no sharing between different threads. There's no memory between those threads. So unlike in Java and Tomcat, perhaps, where you can actually do thread management yourself and share things, you can't do that here. In a traditional server, we see things like this, where we've got multiple threads running, and when a request comes in, that thread handles that request, and it handles it through to completion, which means the entire round trip. So any database lookups that you're doing, any file opens or reads or writes, any access to third-party APIs, all of that request response round trip is occurring in that single thread, and it's blocking that thread the entire time, which means when you start to get subsequent requests, those requests get blocked. So, of course, you know, we increase the size of the server, we add more cores to the machine, so now we've got 8 threads that we can use. Well, eventually those will get used up. Okay, now we add 8 more, we get to 16. Well, eventually those will get used up. And so this is what happens on systems that have multiple threads that are each handling this request where it's not asynchronous. Node, on the other hand, handles things in an asynchronous fashion. So when a request comes in, the one and only Node process that you have running will handle that request. Now, you could have multiple Node processes running, okay? We're not saying that you only have one Node process running, but each Node process is an isolated instance, meaning that request comes in and it's never going to jump around. You're not going to be sharing memory between anything. So one Node process is going to handle this request, but the very first thing that Node process is probably going to do is pass off that request to a callback function. Because what's going to happen is it's going to do something that is going to be asynchronous. So maybe that something is a database read. So maybe the first thing in your request response cycle is I look up the current user, and I do that, maybe you hit a Redis store. So you're hitting a Redis store, well, that call to the Redis store is going to be asynchronous, which means the event loop says, okay, I'm going to pass off that action to this async thread, which is what you see in the gray box there on the right of the gray box. It's going to pass off, it's going to delegate that process to this async thread, which is then going to go do the Redis lookup. Now, when that finishes, your callback function will execute. Well, not quite. Actually, what happens is your callback function is added to the event loop queue. It's added to this queue of stuff that's going to happen. And each time this event loop ticks, that's what we call it, each time the event loop comes around, it processes the next callback that's waiting. That callback might be a new request, or it might be the callback from that Redis check. And what this means is that all of those requests that come in can begin to be processed immediately. So your throughput on your server is significantly increased because all of these different requests can be initially handled, and anything that's happening asynchronous is passed off. So another request can be handled, and another, and another, and another. We'll talk about this again as we get to our web application at the end. What this basically boils down to is you really don't want to be using Node for terribly CPU-intensive tasks. Because if we go back to that diagram, when you get a request that blocks that event loop, so if you're doing something that's not asynchronous, that is very CPU-intensive, and you're blocking this event loop from coming around the next time by not passing it off to an asynchronous action, then you're blocking all of the other requests that come in. So generally speaking, we don't want to be using Node for CPU-intensive tasks. Now, you can use it for those, but you don't want to use it in a typical web application. You would want to pass that off to a child process of some sort. And we're not going to be going into those today, but you can look up the child process API on the Node documentation site for information on that. So what is Node at the core? I mean, it's JavaScript, right? Well, what it really is a stack of things. The bottom of that stack is V8, the engine built by Google for Chrome to interpret your JavaScript and execute it. But in addition to that, we have a number of other things. So libev is a C++ library that's written to handle the event loop. We also have libeio, which is the async IO part of the puzzle here that handles the asynchronous threads that are going to be doing your Redis call, your DB lookup, and things like that. And on top of those things, we have this additional abstraction layer called libev, which handles just some abstractions to these lower level libraries, and also some other things like operating system specific stuff. And then, of course, above that, we have our standard library, which is the Node library that you actually interact with in your application code. It kind of looks like this. So we've got V8 at the bottom, libev, libeio, and libuv down there with it, some operating system specific things. SSL might have different implementation on Linux versus Windows. And then, of course, on top of all that, you've got your Node.js core library, which is all of the APIs that we actually use, so things like the process and other stuff that we'll get to later in this talk. And then, of course, your application at the top. So as I mentioned, I want to go over a few JavaScript fundamentals. As I mentioned, I'm not going to talk about simple things like creating a for loop. We're kind of assuming some programming knowledge here. This isn't an intro to programming course. It's an intro to Node course. And so we're going to talk about some things that are peculiar to JavaScript and things that you might need to be cautious of. First of all, I want to talk briefly about JavaScript variables. We have two different categories. We have primitives and objects, as most languages do. Primitives in JavaScript are immutable. So we have string, number, Boolean, and in ES6 we have symbol, which I'm not going to get into that right now. These primitives have immutable values. I'm going to talk about that a bit. In addition to that, we have null and undefined, which are primitive-like, although undefined is, of course, its own thing, and so is null. And then we have objects. These are things like the date and the array. Functions are objects. If you create a dog class or an employee constructor, those are all objects. And I'm going to talk about those. As I mentioned, primitives are immutable. And what we really mean by this is that the primitive values are immutable. The variable itself, so in this case on the code on the screen there, name is your variable. The variable is dynamic. You can see that I can reassign the variable, and that's totally fine. But the value that that variable points to, the string strong loop, that value is immutable. It never changes. So when we manipulate that string by concatenating it with another string, we're not actually manipulating the original variable. We're creating a new string and assigning that variable to that new string. And the old one will get picked up by garbage collection as that comes around. And this is kind of important to understand because when we start doing things like accessing the length of a string, well, what's really happening? What's really happening is that JavaScript is boxing that value. And we'll see this in a minute. In addition to those basic types, of course, we have null and undefined. And just to be clear, in JavaScript, null is a variable that doesn't really have a value. It's the null value, but the null value is valid. Undefined is the complete absence of any value whatsoever. So there's a slight difference there, and here's some code that kind of illustrates that. Notice that I create a variable called strong loop, but I don't assign any value. So var strong loop semicolon. I could have assigned null, and then it would have had the null value, but instead I didn't assign a value. So the variable exists, but the value is undefined. If I check type of on that variable strong loop, it will be undefined. So the type of value is undefined. If I try and check the type of foobar, which doesn't exist at all whatsoever, it will also be undefined. But this is one of those quirks of JavaScript. If I then try and log out the strong loop variable itself, not type of, but just the variable itself, I also get undefined, as I should. But if I try and log out the foobar variable by itself, I'll get a reference error because the variable doesn't exist. And so this is an important distinction between variables that are created that have an undefined value versus variables that do not exist at all. Objects, we see some object literal notation here, so we use our curly braces to create an object on the fly. Notice that I've given it some properties and values with the colon separating the property name and the property value. And notice that I can access those properties later on by just using the dot syntax. So very similar to a lot of other languages, object.answer is whatever that value is. But I can also use the square bracket syntax. And note that when I use a square bracket syntax, the key is in quotes. This is significant because it means that I can compose object keys dynamically inside of those square brackets in order to build up that key and have some kind of composite key. I can also assign new properties, and this is significant because a lot of other languages kind of restrict you to what you can assign to an object. In JavaScript, objects are very, very open. I've got an object and I can do anything I want with it. I can add properties to it. I can change properties on it. I can call methods on it. All objects have this, and it's important to understand that because anything that's an object you can add a property to. That includes things like your functions, your dates. If you create an employee object, I can add random properties to it in the JavaScript code. So you need to keep that in mind. Objects are very open in JavaScript. We can, of course, create an object this way as well, where you have var obj equals new object with the new keyword there. Notice I can pass in some initial properties, but I can still add properties to it after the fact. And I can still access those properties using the dot syntax or that square bracket syntax you saw earlier. As I kind of alluded to, functions are also objects, and functions, JavaScript functions are one of the most nuanced pieces of JavaScript. So we'll spend some time here, and we'll obviously see a lot of this as we go into more node-specific code. Our functions are objects, so here's how we create one. I use the function keyword. I give this function a name of foo. I indicate that there are no arguments with the open and closing parentheses, and then I create a block using the curly braces, and then I have whatever I need to do in there. In this case, I'm just returning the string foo. And this is a very simple function definition, but I can also define it like this. Notice now I've got var foo equals function var. So what's changed here is this is now a function expression. I've got a variable called foo, and I'm assigning a function expression to that variable. So foo will point to a function object in memory, but what's significant about this is that the foo function, that variable, has a name property which is actually var. And that's because the function I created had a name. That's the bar right before the parentheses there. It's got a name. That name does not correlate to the variable name. The variable name and the function name are completely different. So just a little bit of a quirk, a little nuance there to function creation. We can use an expression like you have here, or we can actually use just a function declaration like you see here. And we'll see both later on. Now we've got another function we're creating here called say hello, and notice that it returns hello plus the recipient. So the recipient here is the argument. It's a named argument, but I could also access it using the arguments array. But I've returned this string hello and then whatever you pass it in, and notice that below I'm calling two functions, right? I'm calling the console.log function, so the log method of the console object. And I'm also calling say hello, passing in world, and of course this will log to our system just like it does in the browser. It would log to our server, hello world. But I can call that function a number of different ways. So in this example, what you're seeing is me using the function say hello as an object and using a method on that object. The method is named call. So I'm executing the call method on the say hello function object. The call method accepts two or more, actually really one or more arguments. The first argument is the context inside that function. The second argument and third, fourth, fifth arguments would be the arguments into that function once it begins execution. Now this isn't terribly important right now because the function doesn't actually use the context. However, when we look at this function, we can see that it's changed slightly. Now we return this .greeting plus and then whatever the recipient is. So this .greeting is going to point to the context, but the question is if I just call say hello like you see on the screen, what is this inside of that function? In the browser, this would be the window object. In Node, it's actually going to be the global object, which we'll talk about in a minute. But either way, the greeting property doesn't exist on that object, and so we would get undefined world. This is a key aspect of JavaScript, is that that context inside of the function can be changed. Remember, that's what we use the hello for. When I'm accessing things like in an array, I can do a.pop for that array, which gives me back the last entry of that array. Inside of the pop method, the context, whatever this points to, will be whatever's before that dot. So a.pop. So a is what the context is going to be inside of the pop method. For our function, we're going to use sayhello.call and pass in our own object with a greeting property and then the argument world into that function. So now we actually print out Guten Tag world, which again, inside the function, you can see it's using this .greeting. So we've passed in a new object, it uses the greeting property on that object, and then concatenates that with the rest of the string to return the final value. So changing the context inside of a function becomes very, very important when you start working with them as much as we will in Node. Notice that there's also an apply method on function object. It works exactly the same as call. You change the context, but then the second argument is an array of the arguments you want passed into the original function. Instead of having them just one after another separated by commas, you pass it in an array. So basically the same thing, slightly different signature. The other thing about functions is that we can use them as values. Functions are first-class citizens in JavaScript, and you kind of already saw this when we used the function expression. Var foo equals function bar, right? So foo is a variable that points to a function. And you see this most often in callbacks. So let's pretend that we have this read file method, which accepts a file name, and a callback method as the second argument. So that second argument, callback, is going to be a function, and we can pass in a function. Notice we don't call that function, we just pass in the function definition. That function is what the read file function is going to execute when it's done. This is the nature of asynchronous programming, is passing in a callback and getting something back once something is finished. Notice that we can also pull that out, though. And this is, again, what's really important to understand is that functions are values, which means I've got a process data variable which I can then pass around just like I would anything else, just like I would a string, just like I would a Boolean. I can pass that function around, and then it can be executed whenever necessary. I want to talk a bit about variable hoisting. So we've got this function here, and variable hoisting is another one of those nuances of JavaScript that's really important for people to understand that is not terribly well understood generally. This foobar function we have here logs out the value of x, and then after that it defines x. It says var x equals 42. So the question is, what do I get on that console.log line? 42? Do I get a reference error? Neither of those is true. Actually, you'll get undefined. And the reason you get undefined is because the variable declaration, so var x, is hoisted to the top of the nearest scope. And we're going to talk about scope in a second, but suffice it to say that scope is the function. So the body of the function, the variable, will be hoisted to the top of the body of that function. So var x will move to the top of the function, but the assignment of the value, 42, will not happen until the line in which you wrote it. In this case, our, what is that, line 4 or 5, the bottom line. So this is what that kind of looks like once it's interpreted by the engine. When it's interpreted by the engine, we see var x at the top, then we log out x, and now it becomes obvious, oh, of course that's undefined. Then we assign the value, x equals 42, and after that line, the value will be correctly assigned to that variable, and you can do whatever you need to with it. So variable hoisting, very important to understand. But there's another nuance to this, in case it wasn't difficult enough to understand, which is variable hoisting with functions. So if I have a function declaration like I do here, remember, that creates a variable called getAnswer. I can reference that function using the getAnswer variable. But in the case of function declarations like the one you see, the entire declaration is hoisted. Not just the variable declaration, not just the var getAnswer. The entire value is hoisted to the top of the function context. So I can actually call getAnswer here just fine. I would get back 42 as expected. So keep that in mind. Function declarations are hoisted to the top, but other variables, things like strings and objects, dates, whatever that might be, only the variable is hoisted, not the value. This kind of brings us to talking about variable scope. So when we talk about variable scope, we can see that functions create scope. In this example, you see we have two variables, y and z, defined at the top. I'm using this single var format, this convention, where I do var y equals 2, comma, z equals 5. That just means I'm declaring both of those. And then I have a function foobar, which creates its own variable z. Inside that function, I log out x, y, and z, and you can see that that will actually print out 1, 2, 3 instead of 1, 2, 5. So z is being redeclared inside that function. JavaScript, when it tries to access the variable, is going to look at the nearest scope and then go up that scope chain. And we're going to talk about the scope chain in just a second. So when I pass in the variable 1, when I call foobar on that before all those console.log statements, I'm passing in x is declared inside that function. So x is actually scoped to the function as well. But if I try and access x, I'm sorry, that's incorrect. Oh yeah, that's right. If I try and access x outside of the function, it won't be declared, and so I'll get a reference error. So remember, functions create scope. Now this creation of scope in a function and the ability to access variables outside of its own scope is the nature of closures. That's basically what a closure is. It's the ability to access your current scope and any scope outside of you when you were declared. So a function, code in a function, can access its own scope, so variables declared inside of its function body, any outer function scope at the time of that function's definition, and of course the global scope, which is wrapping everything. This is an example to illustrate that. You can see that we've got nested functions here, foo, bar, bat, and down right in the middle, baz. But notice that I declare baz at the top. So the baz variable is declared at the top. Then I execute the foo function, which executes all the other functions in line. And you can see right down there in the middle, at the very deepest nest, you can see console.log xyz. So it's getting z from its parent context, it's getting y from the parent-parent context, and x from the parent-parent-parent context, right? So the ability, even though we're executing baz at the very bottom there, right, we don't execute it in the middle, we execute it at the bottom. Even though we execute it at the bottom outside of the context of foo and bar and bat, it still has access to all of the variables in the parent scopes. That's the nature of closures. That's what closures give us, the ability to access those variables at a later time. So getting more into Node specifics. Function arguments in Node. When we start talking about callbacks, we always want that callback to be the last argument.
Jordan, are you still with us? It sounds like we lost your audio. All right, so it looks like we lost Jordan's audio, but he is dialing back in, so sit tight for about 15, 20 seconds before we bring him back online. All right, Jordan, I think you're back.
Yes, I am. That was strange. Not sure what happened there. Sorry about that, folks. So as I was mentioning, function arguments in Node, you want your callback to always be the last argument. In addition to it being the last argument, the argument that it accepts should be very specific. First of all, the first argument in a callback should always be a potential error object. So you can see I've got the read callback there, and it's the error object is first and then the results. Now, it doesn't mean that I'm always going to have an error, but what it means is that if I have an error, I will pass that back as the first argument. If I don't have an error, it would be null. So the first thing that you do, that you check in a callback, is whether or not you have an error. So if error, then you need to handle that error, do whatever you need to do, log it, whatever, and then return, right? You don't want to execute the rest of that code. So error first callbacks are something we're going to see, and we'll see those more as we go forward. So again, some more Node specifics. In the browser, we have this global context, which is the window. In Node, we have the global context, and it's basically the same thing, right? It's the same idea. It is accessible from everywhere, and you can use it similar to you do the window. However, we don't need to do a lot of things that we have to do in the browser because we have a good module system, which we'll get to. So we don't need to do things like create namespaces on that global object. We don't need to do that because we have modules which create their own scope, which we can then require. So again, we don't want to use it the same way, but you have access to it in the same way. So what's on the global object? Well, a lot of things. So if in the browser, we do console.log, but really what we're doing is window.console.log, right? Well, same thing here. We can still use console.log, but really what we're accessing is global.console.log. The process is on global. That require method that we're going to see in a little bit is on global. So everything's on the global object. The node process is your interface to the actual currently executing node process that this application is running in. And that's nice because you can do a lot of things with it. You can access it anywhere because it's on a global object. And it's an event emitter, which means it will emit events so that you can listen for various events to occur and then handle them however you want to. We can get access to all of the environment variables for the current session. So things like the home directory, the port, the node environment, all of these things can be accessed using process.env. It's just a simple object, a simple mapping of name value pairs. We can also access arguments to the command line. So if you're executing something like echo hello world would be the argument. Process.argv allows you access to that command line argument string. However, it's a little tricky because it actually gives you access to the full command, which means that the first thing in the argv array is going to be node if you're executing node. If you're executing something like nodemon, it would be nodemon. The second thing should be most likely your script name. And then after that, you would have anything else that came along in the CLI. So keep that in mind if you're using a command line, if you're creating a command line interface, that argv gives you access to those, but that you mostly want to start on argument number 2. So 0, 1, 2, right? Zero-based indexes. We can kill the process, which might be necessary from time to time. Notice that when you kill a process, you call the exit function, and you probably want to pass in a code. So a successful exit would be 0. If it's something with an error, then put in the proper error code, whatever that is. I think 127 is inaccessible file access error. You can also process events, right? So the process object itself will emit events. So for the first and probably the most important of those is uncaught exception. So if you have any uncaught exceptions, handle them. If you don't catch an exception, it will kill the process. So if you want to handle that exception gracefully and then keep the process running, you need to listen for this event and handle it. You can also listen for other events, and these are usually signal events coming from the terminal itself, from the session. So SIGINT or a signal interruption is, I'm going to die, right? That process is going to die. And what do you want to do right before it dies? So this is your graceful shutdown, closing database connections, file handles, whatever you need to do. And then we get to Node modules. So this is the other big difference between JavaScript in the server with Node and JavaScript on the browser, is we have a very full modular system built into Node. And we access that modular system most of the time using npm. That's how we usually manage those packages. Inside of the code, we use the require function. So this would be some very simple script. You can see that I'm requiring express. I put the result of that call to require onto the express variable, and then I execute that express function and get my application out. You can require things in lots of different ways. So FS is a core module. Express is actually coming from the Node modules directory, which we'll talk about in a minute. But I can also go straight to different JavaScript files within my own application. So in my own application, I might have a router file. I might have a config.json file. And I can go straight to those files using just typical dot syntax. You know, dot slash is the current directory, dot dot says go up one directory. You don't need the .js extension. Node will assume that extension if you don't specify it. And you can see that I'm including a JSON file there. It will just have the JSON object. So the config variable will point to that entire JSON object. Here's a very simple module that we could write. In your module, I might write just a console.log hello world. In my main file, I would do require my module, and then you can see I would get the output of hello world. I might extend this a little bit and maybe use module.exports. So module.exports is what your module is giving back when it's required. So when I execute a require call, anything at all that is on module.exports is going to be returned from that function call and placed on the variable. So in this case, the variable is foobar. Notice that I'm exporting a function here, but you can export anything you want. I'll cover that in just a minute in some patterns. Notice in this case, I'm exporting that function. I say var foobar equals require my module. So foobar now points to that function. So even though the function is named say hello, I execute it using foobar. So foobar open parentheses, close parentheses, and you can see that I get hello strong loop when I execute this on the command line using Node and the script name. There are various different module patterns that I kind of alluded to. These are probably the three most popular, and of course you can combine these along with any other pattern in lots of different ways. But for time's sake, I'll just cover these three. So simple object APIs, I could just do a module.exports with a simple object, an object literal. And I can export some properties like name and version and a method like say hello. Inside of my main script, I could maybe create a variable called API and require that module. And then I can call API.sayHello, and you can see that it would print out hello strong loop. So why not just always use a simple object API? Well, Node caches those require statements. So when I require a module in my application and then I require it again somewhere else in the same application, Node has cached that module. And so it's just going to give me back the cached value. What that means is that you can run into some quirks. So for example, here we've got a little worker module, and you can see the worker module exports a salary and a give raise function. But when I create two workers, you can see that I give them both a raise, but the second one goes to 70,000, not 60,000. That's because that object that we exported is cached and just reused. When I do give raise, it's using the same object over and over and over again. So the strategy to get around that is the function initialization pattern. In this case, you can see that what I'm exporting is actually a function called createWorker, which accepts some options maybe, and it returns an object literal that has the salary and the give raise method. Notice it also has a local variable called limit, which is only going to be accessible to that give raise function. When I require this module down below, so I call var getWorker equals require worker, now I execute the getWorker method in order to get a new worker object. So I'm getting back what that initialization function returns, what the create worker function returns. And now when I call giveRaise, it will be correct. And notice again, I can implement limits, and they can have different limits for different workers. The other pattern is this object constructor pattern, where you're basically returning the object constructor. So in this case, it's the worker constructor, and you can see that the worker has a salary on its prototype and a giveRaise method on its prototype. Essentially acts very similar to what we had before, but notice that in the bottom code block, we require worker and we create new workers. So instead of just calling a method, we're using the new keyword. So if you're doing object-oriented programming already, this would be a little bit more in line with that. So now I want to talk about NPM. This is the Node Package Manager. This is how we get packages into our projects and onto our systems. It's, of course, a website, which you see here. It's also a command line tool called NPM, and they provide both public and private registries for various modules. Notice that you get NPM bundled when you install Node.js, so you should already have it on your system if you have Node installed. The first thing you're going to want to do when you're working in Node, period, is you're going to want to create a package.json file. This is meta information, kind of like a manifest of your project. It's going to define a number of things. You can create it by just running npm init inside your project directory. So you'll get a package.json file, and it might look something like this. Notice that there's a name for my project, version, description. The main line there indicates which file should be run by default, so that's kind of important. We've got a scripts block for things like running tests or what you should do pre or post install. Author, license. There's one other real key here that is missing. There's a bunch of other things missing, but one of the key things here is the private switch. Typically, you always want to define the private switch and make that false to start. Or, I'm sorry, make it true. If you want private to be true, you would set it to false when you want to publish your module. If you set private to true, even if you try and publish a module, NPM will reject it. If you're going to be publishing modules, then you definitely want to set up your NPM user, and that's easy. You can see it on the screen, npm set init.author.name, your name, et cetera, et cetera. And then you'd want to add your user, npm add user. But before doing that, go over to npmjs.org and create an account. Make sure that account matches the email address that you sign up with here with the add user command. When we're installing packages that we have as dependencies on our project, you want to use npm install and then just the name of the project. So in this case, you can see I can do npm install loopback. I can also do multiple installs on the same line, npm install MongoDB space Lodash. And notice that inside my project directory, I'll now have a node modules directory. Oh, it says mode modules. It should say node modules. And you can see I've got Lodash, loopback, and MongoDB in there. So all my dependencies will be installed in that directory. What's also nice is that whatever sub-dependencies those modules have, they will be installed inside of those directories, inside of Lodash and loopback. What that means is that even though loopback might require a specific version of Lodash, you could also use a newer version of Lodash, so you can actually require these things in different ways. However, when you're installing packages that you're going to be using in your project, you usually want to use --save or --save dev. These things allow your dependency to be saved in your package.json file, which means when you go and do an npm install later on, it will just read your package.json and install those dependencies for you. Notice the semantic versioning there, 4.1.12.4 for Express. So that's major, minor, and patch version. And the caret symbol says, hey, I'll accept all updates to the patch version, but not the major or the minor version. That can be really important for preventing backwards incompatible updates to modules that you depend on. Global packages get installed with the -G flag, so these are things like the strong loop tool chain or the grunt CLI. These go into your user directory, not into your project directory, but they usually give you a command line interface. To publish your own module, you just do npm publish. It's really that easy. Make sure that you set that private switch to false and that you've already got a user set up and all that other good stuff. All right, so we're going to start in creating a little basic web application in Node. And we're going to go through it kind of fast, but you'll have the code afterward. And feel free to follow up with us here at StrongLoop if you have any questions. This is the basic server. This is the entire thing. So I've got one file, you can call it whatever you want, server.js. Notice that I require the HTTP module, and that gives me back an object which has a create server method on it. I call the create server method, and I pass it in one argument, which is the callback function. Remember callbacks? Yes, okay. I create a callback function. That function will get executed anytime a request comes into our server. Notice that I write a new head to the response object for that from that callback. So the callback accepts two arguments, a request object and a response object. I can inspect the request to do whatever kind of routing I might need to do, and then I can write things to the response. So in this case, I'm writing a head with a status of 200 and a couple of other headers. I call response.end with the content that I want to send back in that response. However, creation of the server does not start the server up yet. For that, I use server.listen. I pass it in a port and a host, and a callback function of its own, which will be executed once the server is up and running. So I can do any kind of logging I might need to do or some initialization. Again, remember, everything is asynchronous here. So all these things are happening asynchronously. We can run our server just by running node server.js, and it will stay up and running. When I run the server.listen there at the bottom, it keeps that execution open. So this won't actually terminate right away. To terminate the server, you can just use Control-C, and you might have to do it twice if you're on Windows or something like that. And then we just would navigate to whatever port we specified. In this case, it's 8080, which we specified down there in the server.listen. I want to talk briefly about non-blocking I/O again, because again, all of these actions are non-blocking, right? So what's synchronous code look like? You can see something here where I've got a function that creates a ton of objects, and then I do a log statement afterward. And I call the create objects method, and then I do another log statement. And the problem, of course, is that second log statement, the one at the bottom of the top block, is going to wait to execute until all those objects are created. And that can be a long time. Asynchronous code looks something like this, where I might have a method that adds a bunch of records, right? It's doing a bunch of inserts on my database, and then it's going to execute the callback once it's done. So I execute the add records method, and then it adds a callback to the asynchronous action that says, okay, when I'm done, execute this callback. And then it immediately progresses on to the next command. So this is the end. That console.log statement will happen before it's done creating records, because it will happen immediately. Again, what we're trying to avoid is blocking this event loop, right? So when that database action happens, that callback is going to get added to this event loop queue only after the database insert has completed. In the meantime, a bunch of other requests could come in and get processed. And this is what gives Node its speed. This is what allows that really high throughput and allows you to have a much more efficient code base. We mentioned node-side callbacks. Again, remember, error-first callbacks. So anytime we're doing a file read, like you see here using the FS or the file system module, you accept an error as the first argument, and you say whether that you check that to see if it's null or not. And then if it's null, you can go on to process the results. So here's our server again. Let's try and abstract this into a more modular fashion. So let's take that create server, that callback, and let's abstract it to have an actual router. So the first thing we're going to do is define some routes. So this is a separate file, right? So this is router.js perhaps. In our separate file, we might have a number of routes that just have the path and then the content for that path. Obviously, this is an extremely simplified example. In our exports, we're going to export a function, and that function, you can see it accepts the request and a callback. It'll inspect that request, look at the URL property for that request, see if we've got a match to one of our routes, and then return the content if we have it, or maybe an error. So here's what that code might look like. Notice I'm using the URL module here. I use that URL module to parse out the URL for us. Makes it a little bit easier to handle. So I go to the URL parser, I call its parse method and pass in the request.url. That URL, I then check the path name against our routes object that we had on the last slide and up above. And if I have a match, then I execute the callback with null as the first argument. Remember, error first, and we don't have an error, so I pass back null. And then the content for that route. If I don't match something in that object, then I just execute the callback with an error object as the first argument. And notice that I have given it a code of 404, which is the appropriate code for not found. Back in my server, you can see that I still do a create server. I still have a function to handle requests, but the only thing it does is it immediately passes off execution to the router module. So it calls the router method, with the request object and its own callback, which accepts an error and the content. If there was an error, then it changes the status code to that error code and fills the body with that error message. Otherwise, it fills the body with the content that we returned. Now it writes our response head with the status code and maybe some content type or whatever other headers, and then it calls response.end with the body of our HTTP response. And then again, at the bottom, we do our server.listen. So very, very simple routing mechanism that can handle really a lot of different scenarios. So we could obviously update that to handle, we can update this router to handle any number of scenarios. Now, we'd want to maintain asynchronicity here, right? If we look at our router, we're executing this callback immediately. But what if some of our routes needed to do database calls? If some of our routes needed to do database calls and some didn't, we want to maintain asynchronicity. This code is not asynchronous. Yes, we're passing in a callback, but just because you pass in a callback doesn't mean it's asynchronous. This callback will execute immediately when we match a route. Instead, if we're presenting a callback mechanism that looks to be asynchronous, we need to enforce asynchronicity, and we do that by using process.nextTick. So nextTick operates very, very similar to setTimeout, but with a 0 millisecond timeout. So what's going to happen is the next time the event loop ticks, the next time the event loop comes around, it will execute this anonymous function, not right away. What that means is another request can come in and get processed in the meantime. And you might say, well, who cares if one extra request gets processed in the meantime? The difference is enforcing asynchronicity, which is going to be very important when you start your testing and you're expecting this function to be asynchronous and it turns out to not be. So this is maintaining asynchronicity across all of your modules. That's it for me. That's all we have. I know that that was a crash course in Node. We'll stick around and answer any questions. And again, if you want to look at any of the other events, both in this webinar and physical places where Strong Loop representatives will be, check out strongloop.com/developers/events. And hit us up at callback@strongloop.com if you have any further questions or if you're interested in private training or DevOps tools and what we do. Now I'll pass it back to Jimmy. Let me give you the ball.
So as Jordan mentioned, we're going to keep the Q&A box open for a couple more minutes, even though we are here at the top of the hour. So if you've got any questions, feel free to ask those there, and we'll do our best to get those answered up. A few of you are looking for the slides from the last presentation. If you didn't get the email, just feel free to drop us a line at callback@strongloop.com, and we'll get you the information on where to track down the materials from the last presentation. So thanks again, everyone, Paul, Shubhra, Jordan, for joining us today. Let's keep the lines open, maybe another 2-3 minutes to answer questions, and hopefully we'll see you at another presentation in about 2 weeks, and look for an email with the slides and the recording from today's session. Thanks, everyone.